Hello everybody, welcome back to my channel Pharma SL. This is Devi Sarojini. Now I am coming with another video about the differences between GC and HPLC. Both these techniques, GC and HPLC, plays an important role in pharmaceutical industry. So we must know the differences between them to analyze the samples with this operator. Chromatography describes the process of separating and identifying compounds from a mixture of substances. There are several different chromatography methods such as HPLC, GC, thin layer chromatography. In this video, I will discuss about the differences between these two techniques, HPLC and GC. In HPLC method, we use liquid mobile phase, whereas in GC we use gas mobile phase. In HPLC, the sample is mixed with a liquid and is passed through a column filled with a solid stationary phase or solid sheet of the stationary phase. This method identifies the substances by measuring how long it takes for the sample to move through the stationary phase. A detector is used at the end to identify the unique components and indicates each substance's retention time and concentration on a chromatograph. In GC, we use gas mobile phase. This is another popular chromatography technique. This method analyzes volatile samples that are usually gas at room temperature, and a gaseous mobile phase is used to carry the sample through a solid stationary phase. The separation of compounds in the sample occurs in the column based on the length and temperature of the column and the flow rate of the carrier gas. I will explain the differences of GC and HPLC clearly. Mobile phase. In HPLC, we use liquid mobile phase, whereas in GC, we use gas mobile phase. The main difference between HPLC and GC is the type of mobile phase used, which is where the distinction in the names come from. HPLC uses a solvent for the mobile phase, where the polarity, solubility and complexity of the compounds in the sample determine which solvent should be used. On the other hand, GC uses an unreactive or inert gas, also known as carrier gas. The type of gas used depends on the method of detection at the end of the process. Next one, separation technique. The separation of the compound in HPLC is determined by the interaction between each compound in the sample with the mobile phase and stationary phase. This is usually due to the polarity of the sample in relation to the phase. More polar components will move more quickly through the column as they are more attracted to the mobile phase, while less polar components will travel more slowly through the column as it's more attracted to the stationary phase. However, in GC, separation occurs based on the respective volatility of each compound in the sample. Less volatile molecules move slower as they interact with the stationary phase more, while more volatile molecules move faster through the column with the mobile phase. Next one, compound type. The compounds that can be analyzed differs between types of chromatography too. HPLC is used to analyze soluble compounds that can be either volatile or non-volatile. This includes substances such as amino acids, drugs and carbohydrates. But with GC, the sample mixture has to be volatile, which usually means it is a gas at room temperature. This means GC is typically used as a separation technique for air samples and other unknown organic compounds. Next one, temperature. Due to the volatility of the sample, GC needs to be done at a much higher temperature than HPLC. In fact, the column temperature in gas chromatography is usually between 150 to 300 degrees. Next one, in liquid chromatography, the operating temperature is room temperature, that is ambient temperature. Next, speed of elution. Due to the volatility of the sample and high column temperature, GC happens much faster in comparison to HPLC. GC elution can occur anywhere from a couple of seconds to a few minutes. Ultimately, the speed of elution depends on the sample being tested and the carrier gas flow rate. Next one, resolution. After detection, the chromatogram indicates what compounds are present in the sample. However, it can be difficult to distinguish compounds if they have similar properties, resulting in them having indistinguishable detection times. This is known as low resolution. As GC is based on volatility, GC may have low resolution for compounds with similar molecular weight. Similarly, the polarity of the compounds can cause low resolution in liquid chromatograms. Next one, differences in equipment. There are several differences between the apparatus used in HPLC and GC. Column length. In HPLC, the column used tend to be relatively short and wide, measuring up to 30 centimeters length and have an internal diameter up to 8 mm. On the other hand, GC columns are much longer and thinner. Some methods use a column that can be as long as 100 meters with an internal diameter of 0.1 to 1 mm. Next one, solvent used. The solvent used for HPLC needs to be polar in order to work effectively. Common HPLC solvents are water and methanol. In GC, the only requirement for the solvent is that it must be about to vaporize in order to flow with the carrier gas stream. Next one, detection. The detection method varies quite significantly between HPLC and GC. The HPLC detection method is non-destructive, typically using either an ultraviolet visible spectroscopic detector or a refractive index detector, while GC detection uses more destructive principles like in a flame ionization detector that's effective when analyzing hydrocarbons, or alternatively a thermal conductivity detector can be used as it is a universal detection method for GC analysis. Next, cost. On the whole, GC is more cost efficient than HPLC. This is because the solvents used in HPLC are more expensive than buying gas containers, and pressure pump is needed to push the mobile phase through the column in liquid chromatography, which is adds to the cost of equipment. Plus, the cost of GC can be further reduced in long run with gas generators that ensure the carrier gas is available when you need it without costly storage and delivery. Next one, differences in applications. As with many scientific processes, the reason for having multiple techniques is because they have needed for many different applications, all of which have specific analytes that require a different process resulting in different outcomes. GC is typically used to measure oils, organic compounds, air samples, toxins, and drugs. HPLC is more commonly used for inorganic ions and food substances like sugars, proteins, and vitamins, as well as other compounds like polymers, nucleotides, and tetracyclines. This is all about the differences between GC and HPLC. I hope you understand. Thank you. If you are watching my channel for the first time, don't forget to like, share, and subscribe. Please comment your opinion. Thank you.